right, so our next presenter, we have Kirk Marple, the CEO and founder of Unstruk Data, and they'll be talking about knowledge graphs from unstructured data.
Hi, thanks. I really appreciate being here, and what we're talking about today is going to be more of a solution architecture built on Cosmos DB. I have a long time history in the .NET stack and kind of been using it since .NET 1.0 and started out with SQL Server, but then got into Cosmos before it was even called Cosmos. So using it when it was called Document DB. So happy to talk today. Let's see. So sharing. There we go. Perfect. So what we are, this is trying to keep the company part out of it a little bit more, but really what we're talking about today is enterprise knowledge graphs from unstructured data. What does that mean? So unstructured data to us means any type of media that is anything from video to audio to images, even documents and things like that. And so what we're trying to do for businesses is make sense of that kind of data, generate business insights, and leverage machine learning and sort of data architecture so that they can take their images from a drone, take documents, take Zoom recordings, and sort of trigger things in their business automation flow, remove a lot of manual operations, and as well give more access to exploring that data. It all comes back to sort of database indexes. How do you search this data and things like that? So obviously this is our opportunity we're attacking. There's just an amazing amount of unstructured data out there. It's being captured at huge levels. And really the issue we're trying to do is there isn't a service for this. There's things like Synapse for data warehousing, unstructured side. There's other companies that are in this space, but for the unstructured side, there really isn't a great approach other than a lot of times just writing code. Writing Python code, whipping together sort of DIY solutions, and making it scale, and just having that semantic search for the indexing and aggregation is typically very difficult. And so what we've done, leveraging Cosmos DB, and I'll talk about all the other technologies on Azure, is we basically have a platform as a service deployed on Azure today that is many different managed services and code we've written, as well as different ML models and things that attempt to solve this problem for customers. And so really the goal is for a no-code, knowledge-based analytics platform. This is kind of what we do in terms of, be able to navigate the knowledge graph, which is actually driven off of the Gremlin API under the hood, as well as bring in any type of media into the system. And so really this is something for a whole wide variety of folks. It could be for data engineers to explore their data, prep data for machine learning training. It works well for just data analysts trying to make sense of the data that's been captured, and other line of business users. So Unstructured Data Platform, we can basically take any type of data in. We can ingest from any cloud storage location. It could be OneDrive, it could be an Azure Blob container, an S3 bucket. And then the box in blue is essentially our architecture on Azure today. So we're using things like Azure Functions and event grid triggers for triggering file-based ingestion, metadata extraction. So all of this happens within an Azure function, so it's fully scalable, fully serverless. Metadata extraction could mean grabbing the image metadata, the EXIF metadata from images, and it could mean running ML. We're using cognitive services for like text for NLP on extracting documents. And then, but under the hood, the kind of bottom layer here is really the knowledge graph. And that is our data store. And it's something we came up with over the last couple of years where it's a hybrid of a graph database, a kind of SQL JSON document database, and then a search index. And what I found, having the SQL background and starting to dabble in the graph world, there wasn't something that worked well as a hybrid. And so that's what I'm going to talk more about today. And so really all these nodes down here, these are the different sort of nodes in the graph that we extract. And we put a GraphQL API, which works great with a graph database. We put that on top of the system. And we're using a Hot Chocolate, which is an open source GraphQL library for .NET. If you haven't used it, it's awesome. And so that kind of drives the core query engine. And we use things like Gremlin API for graph resolvers. And so the graph is essentially the index to navigate the nodes in the graph, we use the document store, the kind of SQL API from Cosmos, kind of more for bulk load. So we generate IDs from the graph queries and then just kind of bulk load those objects as JSON and deserialize those back into our .NET 6 components. And so, but then the other half is, I mean, for things like driving the user interface and for analytics, you might want to do faceting. You might want to do full text search. And so we have cognitive search integrated into this, where those three kind of make a sort of triad of technologies that sit under our knowledge graph. And so when you go through a process of what we call entity extraction and generating entities in our graph, you're talking to all three at once. And so you're putting an index document into cognitive search, you're creating edges and nodes in the graph, vertices and edges in the graph, and you're putting the full JSON metadata into the through the SQL API. And so on the outbound side, I mean, I won't go into this too much, but essentially you can drive other systems through alerts. You can do it through APIs, webhooks, all that kind of stuff. And then if you want to bring compute from the outside into our system, essentially you can enrich the data that's been brought in by other external APIs. So here's an example, and this is why a graph works really nicely for this, is say you have an image, say it was taken on an iPhone, there's metadata in the image that says, here's the GPS location, and it gives you, I mean, things about the lens that was used, the location, all these kind of things about the time. And so we pull that out, we store that actually through the Cosmos SQL. We then generate tags and what we call observations, which are kind of visual or perceived entities in the data. So we're perceiving that there's a boat there. I mean, we're perceiving that there's a sensor that's on that via computer vision. And so essentially what happens is these are generated in the graph. And then, but the value then becomes is, well, what if I've seen that same term in a document? I can now create this sensor tag. So I have one observation in the image, and the image is actually a node in the graph. One observation in this report, which is also a node in the graph. And then really then it's, we're connecting those two dots via a sensor tag. And so these green lines are literally edges in the Gremlin database. This can then even work for things like uploading a Zoom meeting where we're talking about sensor 17G, and we do text extraction via, say, Azure Video Analyzer for Media, and connect that as an observation from the audio. And so that's really the value of where the graph comes in, of generating the connections between the different entities. And so you typically go through this path of entity extraction, and then which is creating essentially the vertices in the graph, and then entity enrichment. And you're then sort of adding metadata to the nodes, you're creating more edges. And so we go through this kind of staged process. And this can be done manually as well. So through API or user interface, you can connect the dots essentially. But we try and automate as much as possible to make basically those connections and those semantic information exposed more easily for customers. Here's another example. So say, oh, that image didn't come in, but that is a solar panel. And so basically there's an equipment tag that was generated via, computer vision. So we can basically think entity enrichment typically can happen via computer vision. It can happen by NLP, audio extraction. And this then lets people, think of the analytics you can then do by pivoting on, oh, find me all the images that have that were tagged with a roof and a solar panel. And if you had to do that in SQL, it's a much more complicated schema. And so the nice thing about the graph is all we have to do are connect the dots between the edges and the nodes, and we can easily just pivot on any value in the database, in the graph. And that's something we leverage a lot. And if you're familiar with GraphQL, basically these are resolvers. And so we can say, for a tag, show me all the files. And that goes through a file resolver, that goes through the graph, the Gremlin API, and then can bring back a set of IDs that then we bulk load from Cosmos DB SQL and pump into the hot chocolate response. And so how's it done? So what we talk about is we're creating a graph of things. So you've heard of IoT, Internet of Things, and really we are extracting these entities from the real world. And that's really what we're focused on, is what you're looking at in the unstructured data, the images, the video, 3D point clouds, even in documents, it's really about the entities being discussed or perceived in the data. And so we're trying to extract nodes in the graph from that data. We're using all the other unstructured data that's in there, like GPS location and make and model of the camera, and we're analyzing that. And then the idea then is we can take those nodes in the graph and correlate them with structured data. Something we haven't done yet, but we plan to do is say connect to Synapse, Azure Synapse, and say, here is an entity in the graph. So let's, if we look back here, say this sensor tag exists in a structured database, and it is something that's in a data warehouse. We want to be able to automatically query across that boundary from our graph out to a data warehouse. And then what does this provide? I mean, it's really, if you've heard the term digital twin, it's a little bit in that realm. We're trying to provide the context between the real world and the digitally captured perceived world. And I worked in broadcast video for many years, and the video that is captured or generated there typically is consumed by eyeballs. That's really what it's all about. Gets out to Netflix or something like that. But here, the data is really consumed by machine learning algorithms. And so what we're trying to do is automate the process to get data into the hands of these algorithms, but also productionalize the value of the algorithms after they're run. Because a lot of times, I mean, people, there's so much commoditization happening in machine learning where there's a million models being generated. They're all, I mean, awesome for specific use cases, but what do you do with the idea that you found a conveyor belt? How do you hit a Teams alert, or how do you send an email summary of that? And that's really what we're trying to do, is leveraging that data and analytics to then get it back into the hands of other business users. Okay, I'm going to go through some of these are eye charts, so I've zoomed in on these slides, but we'll talk about the architecture and the data model, and so that'll be the second half of the talk. So what we have here on the left-hand side, and I know it's small, but I'll highlight it. So this is where the data is coming from. And so there's a user here going through a web browser. On the left-hand side here, there is basically a handler that is an Azure App Service handler. We're using the TUS protocol, which is a file upload protocol. And the blob trigger that we'll jump into here, it's a little small still, blob created trigger at the bottom. So that's an Azure function that handles saying, hey, there's a new file. The really nice thing about this is that scales really well. And so what we can do essentially is we get these event grid triggers that spin up blob created Azure function handlers. And so these sort of next boxes over are event grid. And so everything is driven off of event grid triggers to Azure functions. And then what we do is we convert that into what I'm calling a post, which essentially is a message on Event Hub. And so this basically puts a ton of messages, one for every file that's coming in. Say if you have 10,000 files on a blob container, it's very easy. It can generate these events very quickly in milliseconds, put them onto the Event Hub, and then we're using Event Hub triggers into more Azure function triggers. And so this works really nicely for an event-driven architecture where you can just dump any number of files in this and we automatically scale out. And then what happens is, so there's a process of entity extraction and enrichment where as we sense that the file is there, so we say, here's an image on a blob container, we pull that data back in, we do different things to it. We look at the metadata, we say, oh, it's an image. What things can we do to images? We have some built-in things that we do to extract that data. We say, okay, we're going to run a computer vision, like cognitive services algorithm on that to identify objects. But we also have made it very pluggable. So if you have models or pipelines that you want to drive against your data, you could say, hey, I have a model over on RoboFlow. I have a model that I built in Azure Custom Vision. We now have hooks that you can extend the enrichment architecture dynamically, basically at runtime. So let's see. So this basically what happens is we go through an indexing step, a processing step, and then a enrichment step. And so what happens is, if we go back here, there's sort of this middle area here that is the alerting, but everything ends up being what's called a entity command batch. And this is something I kind of created and invented for us, where it's a batched list of commands. each command is essentially a CRUD type command. Create, upsert, delete. We have different things like some special operations in there as well for like caching. But the commands go through what we call a command processor, and that's where we talk to Cosmos DB. And so essentially everything, it goes through this command operation. And when we evaluate the command, we say, okay, I'm going to create an entity in the graph, in the knowledge graph. And so that talks to Gremlin. Well, it first talks to SQL API. It uploads essentially the JSON document for that entity. It creates the vertex. So there's a parallel graph and SQL with the same ID. We create the vertex, and then we create all the edges between that and other entities. And so maybe it's tags, it may be metadata as an entity connected to the file. We kind of connect all that up. And then we take basically the search index, which is another sort of parallel to that, and we can put in a special indexing document related to the entity. So we essentially copy some of the data over. It may be for full text indexing. I mean, we use it a lot for faceting, like for drop-down lists and things like that. And so that entity command ends up in 3 places: SQL, Gremlin, Cosmos DB SQL, Cosmos DB Gremlin, and Azure Cognitive Search. And then on top of that, we have basically a function app that uses Hot Chocolate to run queries and mutations. And so really what we built is a data loader in GraphQL parlance and resolvers and mutation base classes that just talk to the knowledge graph. And if it's a resolver, it goes through the Gremlin API. If it's a query, it mostly just basically goes through cognitive search. And so the nice thing about that is we essentially get cognitive search as a cache. And that ends up as a cache for very quick query. And then we basically can bulk load via the SQL API. And that all runs, it's actually we moved it over to an Azure function now. So it's all serverless as well. Okay. So here is another eye chart, but I'll dive into it. So the data model that we're creating, and this is really this is the enterprise knowledge graph as we see it. So there's the concept of files. So you have files that have what we call renditions, which are kind of, a file might be a sort of semantic idea. So it's an image of that boat that we looked at before. But we create a thumbnail of the file. We create a smaller version of it that is compatible with ML algorithms. But then we also have metadata that we extract. And so there's EXIF metadata, there's analysis metadata that might be more like, who is in, like you might see a celebrity or a person in the image. All of that is extracted. So we create these little trees in the graph that is files, renditions, and metadata. We can group files into sets. And then there's also the idea of a project, which is sort of like a folder concept where files can live in one or more sets, but files can only live in one project. So we basically have that those 2 areas. And then we have this idea of, let me actually, observables. I guess I missed that. Observables are kind of real world objects. And so this would be like a place, and it can also be a person or an organization. We use the schema.org schema kind of protocol for the basically mapping entities into the graph. So we try and schema.org drives JSON LD, which is a sort of common schema for knowledge graphs. So we try and canonicalize everything so that it maps to that, as well as add some of our own properties. And really, so we may see, especially from documents or audio or things like that, where it's spoken about a company. And so we would create an entity, an organization entity for that company. Same with a place. And then we could even import, say, like place hierarchies and things like that. And that could be from a geospatial database or some other database. And I missed the one slide here, but on the right, very top right is, we have this idea of an observation. And so an observation, think of it as something I'm perceiving in an image that's linked to an entity. So it's kind of an instance of a tag, or per se, or an instance of an organization. So you may have 10 observations of, say, a conveyor belt in an image across multiple images, but it's the same conveyor belt tag. And so if you think about it, that you essentially have edges from observations to tags. And so really, yeah, I mean, it's our whole entity extraction, entity enrichment model is basically to generate this kind of simple data model. It's canonicalized that then we can start running machine learning algorithms on this. We can do, obviously the schema goes up into GraphQL, so we can expose that to, it drives our user interface, but we're also going to be opening up our public API to this as well. So you can essentially load any data in, configure it with what algorithms you want to use for enrichment, and get really a nice clean GraphQL API from that data to search and navigate and things like that. And so really, I mean, how we did it, Azure Managed Services leveraged heavily. And so, I mean, I've been working in Azure for 5 or 6 years now, have tried pretty much, I mean, all of these and other services. This is really what we're built on. I mean, we do use some other external services for like video transcoding and other ML algorithms, but the backend is all pretty much Azure Functions, .NET 6 now, C#. So some of the benefits we had of, I mean, we're, I mean, not a huge company. I mean, we're just a startup that we don't want to be doing our own ops. I mean, so managed services are great for us. Having the ability to integrate easily with the SDKs, pay as only as we grow. I actually built a version of this on Service Fabric a few years ago and realized just the cost savings by moving to Azure Functions was great, that I wouldn't have to keep a cluster, even just for demo or for test environments. Not having to keep a cluster live is a big benefit. I mean, there's a downside where, yeah, we can't run on-prem, but I mean, there are things that, I mean, maybe we could do in the future to kind of wrap this into maybe a Kubernetes architecture or something like that. But we really like the Azure Functions serverless architecture, and it really gives us really the ability to inherit all the Azure security and reliability features. And finally, yeah, I mean, I think the most unique part of this is leveraging kind of a hybrid index model. And I had kind of come up with it. I researched a bit, found some people had said, yeah, this isn't a bad idea to essentially use the Gremlin as the index, but the SQL API as the data loader, and it worked really nicely. I mean, we haven't had any problems with it. It scales really nicely. We use auto scaling in the Cosmos database to go, I think we're only probably going to like 4K or 10K RU max peaks right now. The most time, any bulk operations like bulk delete or bulk ingest are the things that hammer us hard. But in general, we're not getting hammered too hard by this architecture. It's really nice. And that is about it. And so myself, yeah, I mean, I'm on Twitter. The company's on Twitter. Yeah, if you have any questions, feel free, hit me on LinkedIn, and love to chat about what we're up to.
Thank you so much, Kirk.
Yeah, thank you.
It's also always awesome to see so many Azure services being put together, like and just working together to put something that's greater than the sum of its parts.
Yeah, we've definitely tried most everything, and so it's a little mix of everything. And it's, I mean, I'm a Microsoft alumni as well, so it was kind of in my blood to go the Azure direction, and it definitely has worked out well.
Yeah, I really like seeing all of those different Azure services working all together. Lastly, you mentioned how many RUs were you using for your service all together?
Yeah,
sorry, go ahead.
Oh, no, sorry. So, I mean, we're auto scaling up to, in some environments, 4,000, some into 10,000, but on average, we're still very low. But the burstability is great.
Yeah.
Like when we do like a bulk delete operation or some kind of bulk ingest, we can, I mean, peak up well, but then we're not paying for the rest of the day when that happens.
And is that across your both SQL and your Gremlin accounts?
Yeah, so I think right now we're set, I think in general, our default is 4,000 RU to the top for both accounts. But I think in demo and prod, we're at 10,000. We set it higher. So.
Yeah, it's always great to see good feedback on the auto scale and just being able to quickly scale up and down as needed.
No, it's been great. And I think it's, I mean, functional, we haven't taken use of like some of the backup features or anything like that, but I think that's something we're going to probably have to do ourselves since we have to keep all the databases and the search engine in sync. But yeah, I mean, in terms of all the other functionality of Cosmos, it's been great.
I was wondering if you could talk a bit more about your experience combining kind of Cosmos DB and functions together to build this more serverless architecture.
Yeah, for sure. So basically everything we're using, everything kind of starts with basically a dependency injection service. And so we kind of have like a repository service that I built that is around Cosmos DB, and then there's a graph service that's similar. So everything kind of just driven by, and we're able to, it's nice because then we can test it directly. So we kind of build up these services. And then in the Azure function, we basically dependency inject a repository service and a graph service. And then essentially we're using a pretty common pattern of like having a type field in the document. And so we can basically have multiple object types, just it's in the same container. And then within Azure Functions, I mean, here's a good note of we were looking at using caching with the Azure Redis cache for Redis, and noticed that Cosmos was so fast; it was actually faster than Redis. And so, I mean, we were getting our queries back in, I don't know, just a 10 milliseconds or something like that from Cosmos, and I was like, there's just no point. I mean, to even cache this somewhere else because it's actually faster than Redis. At least in our, I mean, we don't have a big Redis cluster, but I saw the question about the Cosmos databases. I mean, right now they're generally small. I mean, they're in the tens or hundreds of gigabytes because we're just a metadata store. So the data in there, we're pointing to URLs on blob storage. So we're not keeping any of the raw unstructured data in Cosmos. It's really purely just a big index.
Makes sense. I think that pattern is actually quite common. We've actually seen it with a few presenters today, having a great metadata store indexing layer, Cosmos DB, and then a lot of the actual files in something like blob storage or something better equipped to handle those.
Yeah, it works, and that's where we essentially just, when we're processing, we're actually using durable functions as well and durable entities. And so we have things like a watch folder. So we spin up like a durable entity that kind of watches a folder and then wakes up every so often, and then that basically spits out messages back to, I guess, Event Hub. Yeah, and so then, but the nice thing is you get that buffering and that scale by processing Event Hub in Azure Functions. So. But everything runs back through this little command processor that I built, and that's where kind of all the federation into the different databases go.
Sounds great. Always great to see great architecture with Cosmos DB, Functions, Azure Event Grid, Event Hub, everything together.
Right on. No, we've been happy with it.
All right. Thanks so much, Kirk.